We want to find some value for c, which c is right here. It's just some number that makes this function continuous everywhere. Well, first let's investigate each piece. The top piece here, the first piece, x squared minus 3x plus c. C is just some number, so this is just a parabola, and that's continuous everywhere that it's continuous everywhere on the domain that we set for it. There we go, which says x is less than or equal to 4. So this is continuous from negative infinity all the way up to 4, no problem. Well, I guess it's not, might not be continuous at 4 because it stops at 4, so we don't know what's happening on the other side. Like, I mean, it could come up and stop, and then something could continue like that, you know? So we don't know if it's continuous at 4, but everywhere else it is continuous. We know that it's just one nice parabola like this or something like that. I don't know. Just looks like a parabola. There you go. So that's happening. And after we pass 4, well, now we're just on this line, and this line's continuous everywhere too. So for any value greater than 4, there's a point for this, and it's continuous. So basically we have a parabola that has a little point at the end of it because it's equal to. So at 4, we're going to plug it in and get that back. And then we have some line, which goes off like that. Open circle goes like that. If we want this to be continuous, well, we're only worried about one point, and that's where this thing splits. What we need is for this thing to really be down here. That's what we need to happen. We don't need it to be up here where this stupid hole is. That doesn't do any good for us. We need it to be down here. And as long as it meets, as long as it meets that function, this first function, where it ends, then it's continuous. So really, when I say find c that makes this thing continuous, all I'm really saying is find a c so that at 4, this thing stops at 4, where this thing starts off. So when I plug 4 into this function, I have to get the same thing as when I plug 4 into this function. And what we're really doing there is making sure each piece meets. So we need to plug 4 into the top part, and that's going to give us 16 minus 12 plus c had better equal the same exact thing as where this starts at 4. And 4 times a half is 2 minus 4. So this side's negative 2, and this side is 4 plus c. So c has got to be negative 6. If c is negative 6, so if this is in here, if there's a negative 6 here, then this parabola is continuous the whole time, and when it gets to 4 and stops, this second function right here just starts right up and at negative 2. And yeah, that's it. And that means, so the parabola is going to go like this and stop at negative 2, and then the line just takes over for it, right where it ended.